Welcome back to the deep dive. Based on the sources you've shared, we're really getting into a challenge that so many of you in enterprise tech face daily, just keeping up with complex cloud stuff.
Yeah.
It's so easy to feel buried in information, right? Trying to figure out what actually matters for your own setup. Okay, so let's unpack this. Today, we're using those sources, which are a great set of practice questions and some really detailed explanations as our way into the core stuff around VMware Cloud Foundation, VCF. Our goal here isn't just, exam prep. It's about pulling out the key insights that make you genuinely clued in about VCF, whether you're designing it, rolling it out, or fixing it.
Exactly. And what's great about these questions is they cut right to the chase. They hit the practical challenges, the architectural bits of VCF. It's not just memorizing facts. It's really about understanding how VCF works, from getting it deployed to keeping it running day to day. Hopefully this deep dive will clear up some common confusion points, give you a few of those aha
Yeah.
moments.
Yeah, I think we can turn some potential headaches into real insights today. So let's jump right in. One thing that comes up again and again in the sources, and I hear this from listeners too, is managing VCF when it gets big. Like running one instance is one thing, but what if you've got a whole fleet? Different regions, different environments. That sounds like it could get messy fast. So what's the big step forward in VCF 9.0 that helps tame that complexity? Unify managing multiple VCF deployments.
Right. This is a huge deal for bigger deployments, something people have really been asking for. The answer is VCF operations. It's a brand new piece, specifically in VCF 9.0. Think of it like mission control for your whole VCF setup, your entire fleet. It gives you this centralized management layer, a single place, a unified platform to look after multiple VCF instances. So this means you can centralize those big, sometimes painful fleet-wide jobs. Like think about credential rotation, huge for security and operations, and certificate lifecycle management, getting an overall health check across all your VCF instances. It really changes the game for managing complex setups, addresses a massive operational headache for big companies, cuts down the admin work significantly.
Okay, so the key difference then. SDDC Manager is great, but it's for one VCF instance. VCF Operations takes that idea and scales it up. Fleet-wide management.
Precisely, yeah. SDDC Manager is your go-to for a single instance. Absolutely essential. But VCF Operations, it extends that, give you that enterprise-level view, that fleet-wide control. It shifts you from managing individual boxes, basically, to managing this coherent, integrated cloud foundation across the board.
That sounds crucial. A really important evolution. Okay, so let's shift gears a bit. From managing the fleet down to the nitty-gritty of actually building VCF. The sources point out that sometimes even experienced teams stumble right at the start, like when creating a VCF workload domain leads to annoying delays. What's a really common but maybe easily missed reason for that workload domain creation to just fail? Something that could save people hours of digging.
Oh yeah, this is a classic. A seemingly small detail that can totally derail things. The critical thing here, the step people sometimes miss, is you absolutely have to commission the ESXi hosts in the SDDC Manager inventory first, before you even try to create that workload domain. If you skip that step, well, SDDC Manager just can't see or allocate those hosts. They're invisible to it for deployment purposes. And boom, the deployment fails. It's like trying to build a house, but the bricks aren't even on the site yet. SDDC Manager just doesn't see the resources. I've seen projects get seriously held up by this one simple oversight. It's often the basics that catch you out, Sure, other things could cause issues, maybe licensing or an appliance isn't available, but honestly, for this specific failure, the most common culprit is forgetting to commission the hosts. Understanding this isn't just ticking a box, it's about seeing potential problems before they happen, making sure things go smoothly right from the start.
Right, so forgetting that basic host commissioning step. Total showstopper is those foundational prerequisites that keep you on your toes. Speaking of foundations, let's talk about the absolute core of VCF, the management domain. That's where all the brains live, right? vCenter, NSX, SDDC Manager. Now, for high availability, making sure it's resilient, no single point of failure, what's the bare minimum number of hosts you need there?
Okay, yeah, good question. For a production VCF management domain, if you want proper HA, you need a minimum of 3 ESXi hosts. And that's not just some random number. It's baked into the architecture. Comes straight from vSphere best practices for cluster quorum. See, the management domain runs on a vSphere cluster. And 3 hosts is the magic number to make sure HA actually works properly. Think about it. If you only have 2 and 1 fails, you lose quorum. Your ability to keep those critical services running is Well, it's shaky at best. With 3 hosts, if one fails, the other 2 can still maintain quorum. They can handle the failover for those essential management bits, which means your VCF environment stays up, stays manageable, even if a host hiccups. It guarantees that core resilience, protects those essential services, keeps the whole thing running.
Ah, okay. So losing a quorum with just two hosts basically leaves your whole management plan exposed. That makes sense. It really highlights the thinking behind protecting the brain of VCF. Okay, so we've got our management domain resilient. Maybe we're starting on workload domains. The next big question, especially for companies with existing gear, is storage. VCF means vSAN to a lot of people, but are you really locked into just that? Specifically, what's the story with Fibre Channel? Can you use it in a workload domain?
Yeah, that's a really important point because while vSAN is the main storage, especially for the management domain, it's definitely not the only game in town for workload domains. The sources confirm it. Fibre Channel is absolutely supported as supplemental storage in a VCF workload domain. So what that means is, okay, vSAN might power your core stuff, maybe your first workload domains, but VCF isn't totally rigid. It's not one size fits all. You've got flexibility. You can bring in other storage types if you need them for a specific workload. So, workload domains. Yeah, they can definitely use things like NFS or VMFS on Fibre Channel, even Vivols. Now, Fibre Channel isn't required, right? It's not the default. But it is a fully supported additional option, lets you meet different storage needs. Maybe you have a big Fibre Channel SAN already or specific performance requirements. That flexibility is super important for hybrid setups and bigger companies with diverse needs.
That's huge, especially for those hybrid places. It means VCF doesn't have to be a rip and replace for storage. You can integrate existing, maybe expensive fiber channel investments. That must make adopting VCF easier for a lot of large organizations.
Definitely simplifies things.
Okay, finally, let's tackle a specific, kind of annoying troubleshooting scenario. Picture this. You've got two VMs. They're in the same workload domains that they could chat easily. But here's the catch. They're on different logical segments, and they just cannot communicate. Ping fails, everything fails. Our sources point to one really likely and sometimes overlooked cause here. What's probably going on? Why might routing not be the first place to look?
All right, this is a classic one. Sends people down rabbit holes sometimes. In this specific case, same domain, different segments, no communication. The most likely cause isn't routing itself or some big network outage. It's probably a firewall rule blocking the traffic between those segments. So let's break that down. In NSXT, yeah, VMs on different segments need routing. That usually goes through a tier 1 or maybe a tier 0 gateway. That part has to work. But even if the routing path exists, NSXT has these super granular distributed firewall rules. And they are a very, very common reason for blocking what we call east-west traffic. That's traffic between VMs inside your data center, not stuff going in or out. Maybe it's blocked by design, maybe accidentally. But that rule effectively acts like a security guard stopping traffic between those specific segments. Other stuff, like vSAN network problems, MTU issues on the switches, maybe the tier 0 gateways down, those usually cause much bigger, more widespread problems, not just these two VMs in different segments being unable to talk. So yeah, it really shows you how powerful and granular that distributed firewall is, but also how it can be the first thing you should check when VMs can't communicate like you expect.
So even if the road is technically open, that NSXT distributed firewall can just put up a roadblock silently. Okay, how do you even start figuring that out? Is there a quick check or do you have to dive deep into NSX policies?
Ah, excellent question. There's actually a great tool for this. Often the first step is to use NSXT's built-in traceflow tool. What traceflow does is it basically simulates a packet going from VM-A to VM-B, and it shows you the exact path it tries to take. Crucially, it will tell you exactly where it gets dropped or blocked and why, including if it hit a specific firewall rule. So you can literally see, okay, packet reached this point, firewall rule number 5 blocked it. It lets you visualize the flow against your rules. Helps you pinpoint if it is the firewall really quickly before you start chasing ghosts and routing or the physical network.
Wow, okay, Traceflow. That sounds incredibly useful. Really practical tip there. Knowing about tools like that can save, I imagine, a ton of time.
We hope you reflect on how these insights connect to what you're working on or what you're interested in. Because really, understanding these principles, these common pitfalls, it just makes you better prepared for whatever the future of cloud infrastructure throws at you.